Now let's look at Bayes theorem, also called inverse probability theorem. Inverse probability theorem. It states this way. Statement goes like this. Let A1, A2, An be n mutually exclusive and exhaustive events. Mutually exclusive and exhaustive events. Now, E is an event. E is an event which occurs as a consequence of one of these AIs. So one of the AIs triggers this event A, E. So that is one of the AIs will be the cause for the event E to happen. Then, given that E has occurred, what is the chance that the probability of it has occurred by virtue of AK, some K ranging from, K can be any one of these n events, right? AK can be any one of these n events. Then probability of AK given E is probability of AK intersection E divided by probability of E. That we can write it in this form: probability of AK into probability of E given AK divided by sigma probability of AI into probability of E given AI, I ranging from 1 to n. Actually, the proof goes like this. Now, before actually going to the proof, we'll just analyze what we are trying to calculate here. So, let me show it in the form of a figure. A1, A2, An. Any one of these n events may be the cause for event A. May be the cause for this event A. Now, let's say you are given that E has happened. E has occurred. You are given this. So, given E has occurred, you want to know the chance that it has occurred by virtue of A1 or by virtue of some A2 or by virtue of some AK. That is what is being calculated. That is, given that event E has occurred, which could have been caused by any one of these n events, what is the chance that it has been caused by a particular event A1 or A2 or some AK? That is being asked you. That is being given in a kind of a formula here, and that is quite an obvious. Comes in 2 steps. The proof of it goes in 2 steps. As you will observe here, by multiplication theorem of probability, now probability of AK intersection E is nothing but probability of E into probability of AK given E. So, probability of AK given E will be this. So, this implies probability of AK given E will be probability of AK intersection E, which is nothing but probability of, that can be written again as probability of AK into probability of E given AK divided by probability of E. So that is probability of AK given E. I am writing it as probability of AK intersection E divided by probability of E, but the probability of AK intersection E can also be written this way, that is probability of AK into probability of E given AK. E given AK. Alright. So now this event A could have been caused by any one of these n events we said. So by total probability theorem, probability of E, by total probability theorem, probability of E is equal to sigma of probability of AI intersection with E, which is nothing but, I range from 1 to n, which is nothing but sigma of P of AI into P of E given AI. I range from 1 to n. This is again multiplication theorem of probability that I have used here for each term in this summation. Okay, so this is what I am writing, and this can be simply, this has been substituted. In place of P of E we are writing this, and in place of P of AK intersection E we are writing P of AK into P of E given AK. We will see some applications of this Bayes theorem in the form of some illustrations. Okay, let's look at this illustration. A bag contains 2 white and 3 black balls. Second bag contains 4 white and 5 black balls. A bag has been selected at random and a ball is drawn from it. It was observed that the ball was white. So the ball drawn was, I don't know which bag has been kept there, but I have drawn one ball from there, and it was found to be white. What is the probability that this selected ball, which was white one, has been selected from the first bag? Okay, so let us, this is it an application of Bayes theorem? It is. Here this event, let us look at it this way by naming the events here. Let A1 denote event that first bag was selected to draw a ball. A2 is the event that second bag was selected to draw a ball. So we have drawn one ball. So it could have been taken by, it could have happened by virtue of A1 or by virtue of A2. E is the event that selected ball from the selected bag, selected ball from the selected bag is white. Now this event E could have occurred either by virtue of A1 or by virtue of A2. So it is A1 which would have caused. Okay, now I want to know what is the probability that it has come from the first bag. That is, given E, what is the chance that it has come from the first bag? So by Bayes theorem, we can write this as probability of A1 into probability of E given A1 divided by the total probability, that is P of A1 into P of E given A1 plus P of A2 into probability of E given A2. What is the probability of A1? Now, any bag could have been selected at random, so nothing has been specified about it. So one bag is selected, so P of A1 and P of A2 a priori, that is prior to the happening of this event, there is equal chance of, we can say that there is equal chance of any bag has been selected, so it's 1 by 2, 1 by 2. Now, as it appears, the second bag has 4 white and 5 black balls. So it appears that there should be more chance that to get a white ball from the second bag than from the first bag. So if in the light of this event, E, that is the ball drawn was a white one, you will observe that you can say that there is more chance that it has come from the second bag. So okay, so probability of A1 given E is lesser than probability of A2 given E. Let's see whether it happens or not. So we will calculate this inverse probability, that is given E, what is the chance of A1 occurring. Unconditional probability, that is without the condition of the occurrence of this event, their probabilities are equal. Okay, now what is probability of E given A1? Let's calculate this. That is, given that the first bag has been selected, what is the first bag? First bag had 2 white and 3 black. So what is the probability of E given A1? So there are only 2 white, you are selecting 1 ball, so 2C1 by 5C1, there are totally 5. So that is 2 by 5. Now what about probability of E given A2? Now what is A2? A2 is the event that second bag has been selected. So if the second bag has been selected, the bag would look, what is the bag composition? 4 white and 5 black. Now one ball is being drawn from such a bag, given that the second bag has been selected. So the composition of the bag would have been 4 white and 5 black. Now you are selecting only 1 ball and that has to be a white one. So 4C1 by 9C1 is a probability. That is, from 4 you are selecting, favorable cases would be any one out of the 4. Right? The total number of cases are 9 such balls are there. 9 from 9 you are selecting 1. So 4C1 by 9C1, that is 4 by 9. So you can just plug in these values here. So probability of A1 given E will be, that is, given that the ball drawn was from a randomly selected bag was white, what is the chance that it would have been the first bag that we have selected? Okay, so what is that? Here half into that probability of E given A1, 2 by 5, and here in the denominator half into 2 by 5 plus half into 4 by 9. So that makes it, this half can be cancelled and you have 2 by 5 divided by 2 by 5 plus 4 by 9. So that makes it here 18 plus 20, 20 by 14, 45. 18 plus 20, 38 by 40, 45, 38 by 45, and 2 by 5 here. So that is 2 by 38 into 45 by 5, 9, and then we have 19, 9 by 19. So it's 9 by 19. Then obviously the probability of A2 given E would have been 1 minus 9 by 19, that is 10 by 19. So you see that unconditional probability is one and the same, that is prior to the happening of this event that we are given that the event has happened, E has happened. We know their probabilities are one and the same because you are drawing a bag at random, so it is equal probable that you draw first bag or second bag, so 1 by 2, 1 by 2. But now, given that event E has occurred, so the chances have slightly changed according to our Bayes theorem. So this is what we have here.